So in this video we are looking at 3 exam questions for functions, and our first question here we have a part A with 2 parts, so we're doing our composite functions. So I'm just going to plug in g of x into f for the first one. From there I can cancel out, so the 1 and minus 1, the root and the square, and with the root gone, of course, the 4 and the minus 4 as well. You can do that separately if you want as another step. But either way, it's the same thing. So x is our answer for f of g of x. And now we're going to do the opposite of that. Or is it the opposite? We'll see. So g of f of x, we plug f of x into g, as we always do with our composite functions. So just a reminder that I've replaced the x in each of those functions. Just make sure the root carries on where you need it. So cancel out the root and the square. Again, the minus 4 and the 4. And the same thing with the 1 and minus 1. So you actually end up with the same answer. So of course, we have something very interesting here. That f of g of x and g of f of x are both equal to x. Which leads us into our second part quite nicely, actually. So we need to write down the inverse for f of x and state the domain and range. So of course f of x and g of x, as we've just seen, are an inverse of each other. And just remind yourself of this, that when you look at the domain of an inverse, it would be the same as the range of the original, and vice versa. So the inverse of f of x is in fact g of x. Draw a little sketch if you're not sure of that initially. So you'll have your domain on the bottom with the x values, and your range along the side with your y values, for instance, and you'll see it more clearly there. In this question we're going to look at some transformations, so basic enough kind of transformations. So we're going to state the coordinates of the image of the point that we're given, which is minus 3, minus 2. So the first one, we've got a vertical translation, and so it's the y. You can cancel minus 2 on both sides and you get minus 4. So it's the y value that changes there. Next one, we have inside the brackets a minus 3, so it's a horizontal translation. So anything inside brackets will affect the x. So we end up with 0. Minus 2, 3 minus 3. The third one, so y is equal to a half f of x, if you will. So we have a vertical stretch. And just keep in mind that it's outside, so it's affecting the y, or the vertical, we'll say. It's a vertical transformation. So minus 3 minus 1. And the last one here, we have a horizontal stretch. Be very careful with the x's, they're a little bit opposite in a sense, especially when it comes to the combined transformations. So it's times 1 over a. You do the opposite in a sense when you do horizontal transformations. So just be careful with that as an initial thing for this one. In the next question we look at it more deeply for combined transformations. So in our next question, we've combined transformations, as I just stated, and we're going to look at this from a certain angle. So if you're dealing with inside brackets, remember, you do them first. If it's inside, like this minus 1 here, it's a horizontal transformation. And remember, the opposite happens, so translations are first, for instance. So again, a 3 of x would be a horizontal stretch, so scale factor of 1/3. Be careful with that, especially that fact is a little bit unruly. And then of course we have a vertical reflection in the x-axis. We can say that y is equal to 0 as the minus out the front. Remember, the y values that are changing are outside the brackets. Y outside, whatever, some kind of mnemonic device for yourself. 5 minus x and a scale factor of 2. So we have a 5, that's the translation, so it's positive 5, which means it'll be a minus 5 on the x-axis. It does the opposite, as I said, for a horizontal transformation. And then we have a horizontal reflection in the y-axis, which is x is equal to 0, we could say. And lastly, we have a vertical stretch. And again, it's outside, so it's a y-valued one. So the scale factor of 2, it's a normal arithmetic, we'd say. So just looking at these, the horizontal and the vertical transformations, be very careful with how they combine, especially if there's two of them. If there's one of them of each, it doesn't actually make much of a difference. But you will have to look at it in isolation and practice a few questions.